Okay, so as we previously discussed, uh, we're going to do the first half of a bunch of IGCSE papers um, as some work for you guys to do. We're not going to be at school, so this is the best I think I can come up with. So what I've got here is a copy of uh, a higher paper from, you can see there, 2007. I'm making notes from a pen. It's the paper 3H. There's a paper 3H and there's a paper 4H, so two higher papers that you have to sit anyway. What I'm going to do is I'm just going to go through the first half of the paper, so maybe like the first 10 questions, maybe something like that. Okay, so let's go through this nice and easy. So these are the formulas that you might be able to want to use. The important ones for you guys, I think, are this one here, Pythagoras' theorem. These ones here, your trigonometry ones. Area of a trapezium, this one over here. You'll need these ones are nice and straightforward. The cylinder ones, this one here, is usually a little bit harder to do the questions for that, so I wouldn't really recommend those. Similarly, these triangle ones over here, they're also a little bit harder to do. But the other ones that I've circled are always going to be nice and straightforward questions. So let's start with this. I've got my calculator next to me, so I'm not doing all this in my head, unfortunately. It says, question number 1, use your calculator to work out the value of 3.7 plus 4.6 all squared over 2.8 plus 2.6. Right, so all I'm going to do, literally, I'm going to put that into my calculator, start with a fraction, and then brackets 3.7 plus 4.6, close brackets, squared over 2.8 plus 6.3, click equals, and it says write down all the figures on your calculator display, and on my calculator it says 6889 over 910. Now that's what it says, but I might also put it in like a regular number just by pressing that SD button on my calculator. So that's, oops, 7.57032967. Now it says give your answer to part A in 2 decimal places. So if we're looking at decimal places, what we're looking at are all of these guys right here. Those are all the decimal places that we need to have a look at. So realistically, it says 2 decimal places right there. Oops. It says 2 decimal places right there, so I'm only going to be looking at these 2 decimal places here. So my answer is going to be 7.57. Now, if the 3rd decimal place, that one right there, if that one were 5 or more, then the answer would be 7.58 because it would round up. Okay. Let's move on to question 2. Work out the value of x squared minus 5x when x equals -3. Okay, so x equals -3. We're just going to put that value of x into this thing right here, and I'm going to get -3. Being really careful with my brackets here, minus 5 times -3. Because if you put just -3 squared in your calculator, it will equal -9, which is wrong. Unhappy face. But if you put -3 in brackets squared, that equals 9. That is correct. So that gets not another unhappy face. That gets a happy face. Yay. So we're going to get this. I can just put that straight into my calculator, which I'm going to do right now. Brackets -3 squared minus 5, I'm literally doing exactly what I've written there, times -3, and that equals 24. So I'm going to write 24, and that will get me full marks. Now, factorize means find anything in here which is a common factor. So I can see that x squared is x times x minus 5 times x. So a factor of x times x is x, and a factor of 5 times x is also x. Another factor would be 5, and over here the other factor would also be the same thing, x. And it means put it into brackets. It means take everything out of here, all the factors, put them outside of a bracket. So I look at my common factor, which is x, and then I take that outside the brackets. I put everything else that's left inside the brackets. So I've got x minus 5. And if I wanted to expand those brackets, it would be x times x minus 5. It would be x times x, and then x times negative 5, which is x squared minus 5x. So our answer right here is going to be x times x minus 5. Okay. Next question, question number 3. Hadra counted the number of sweets in 20 packets. The table shows information about her results. Okay, so, wow, that's a lot of sweets. Must have taken her ages. Right, so number of sweets is 46. So there are 3 bags that she counted, and in 3 of those bags there were 46 sweets. In 6 of the bags there were 47 sweets, and 3 of the bags there were 48, and so on and so forth. And in total she counted 20 packets. Frequency just means the number of times. So the number of times something happened. So 3 bags with 46, 6 with 47, 3 with 48, etc. It says work out the mean number of sweets. Now the mean is the average. Okay, it's the average number of sweets. That's what we want to know. Now, if it were just regular mean, we take up all the numbers and we add them together and we divide by the total number of things. So for example, if I got the numbers 5, 7, 9, 10, 11, and 15, I've got 6 numbers there, and I would do 5 plus 7 plus 9 plus 10 plus 11 plus 15 divided by 1, 2, 3, 4, 6. So again, on my calculator, that is 5 plus 7 plus 9 plus 10 plus 11 plus 15 over 6 equals 9.5. And I've just done that on my calculator. But here, what we've got is we essentially got 3 46s. So these numbers, the sweets here, those are the pieces of information that we have. So we've got 46 sweets. We've also got another 46 sweets. We've got another 46 sweets. Then we've got we've got a 47 sweets and another 47. And I've got 6 of those. So instead of writing them all out, I'm going to actually write it in a different way. I'll write it in blue because we all like blue. And it's 46 times 3 because that's what we've got there. And we've got 47 times 6. So that 6 there, you can see, comes from there. And we've got 48 times 3. We've got 49 times 5. Okay, I'm just going to erase these bits over here. They're not needed anymore, I don't think. See ya. So what are we going to have to work out here? Well, it's the same thing. It's the same type of principle. You've got all the numbers added together and then divided by the number of things you've got. So 46 times 3 plus 47 times 3. So each time I'm just multiplying those two things together. Plus 48 times 3 plus... Oh, hang on, I've gone wrong already. That shouldn't be 47 times 3. That should be 47 times... Not even 9. Can't see. Times 6. Yeah. And then 48 times 3 plus... Okay, I need to get rid of these guys here as well. See you later. Sorry. 48 times 3 plus 47 49 times 3 plus, oh God, I'm obsessed with this number 3. 49, not times 3, 49 times 5. And then let me just check, 50 times 2 plus 51 times 1. And the number of pieces of information I have is the number of bags that we counted in the first place, which is 20. So we divide all that by 20. And then using our calculator, ooh, this is a long calculation, 46 times 3 plus 47 times 6 plus 48 times 3 plus 49 times 5 plus 50 times 2 plus 51 times 1, all divided by 20, and I get the answer 48. So the answer is 48. All right, next question. It says, describe fully the single transformation which maps P onto Q. So a transformation is essentially just a movement. That's all it is, really. It's some way of getting one shape onto a different shape. So here you can see P is going to Q. It's the same shape. This one's a nice and straightforward because it's just moving. It's not rotating. It's not enlarging. It's just moving. So it's actually going that way. It's going right 3 and down 1. Okay. Now, this has to be written in a very, very specific form. It's using a thing called a vector. So the vector looks like this. It's a bracket with a number on top and a number below. And you've got, if it's positive here, then it means going right. If it's negative here, it means going down. So your top number is your left, right. And if it's left, it's negative. If it's right, it's positive. And your bottom number is your up, down. Up being, oh, I'll change those the other way around. Bit of consistency. Down, up, and down is negative, up is positive. So if I wanted, for example, to go from Q to P, then it's going left 3, up 1, which would be negative 3, 1. Okay. Describe the part B. Describe the transformation which maps triangle P onto triangle R. Okay. Now, the first thing I can see is that it's rotated, because if I look at that point there, if I look at the corner point, I can see that this line here turns into that line there. So it must have rotated in some way. And imagine if you took this triangle P right here, yeah, and you kind of flipped it round once, it would go to there. Flipped it around twice, it would go to, where would it go to? It would go to there. Will it? Go once down to there, another one down to there. Yeah, it would go like that. So I can see that it's been rotated, but my question is, the hard thing is, okay, so from where has it been rotated? Let's get all that. Let me see. Now, I can get some marks anyway. First, I can say rotation. I know it's clockwise. That's one mark to say clockwise. And I know it's 90 degrees. That's another mark. So you've got one mark for that, one mark for that. And then the other mark is to say where it's rotated from. I can, let me just think where it has rotated from. Draw a line between the two like that. I think it's been rotated from here. Yeah. Yeah, there's no easy way of doing that, unfortunately. But I can see that it's been rotated from the point to 1, and that's your third mark right there. If I were you, I would just go for those first 2 marks. It's easy to see that it's gone clockwise, and it's easy to see that it's gone round 90 degrees. Where is just that extra mark. Right, let's go on. Simplify this in index form. Okay, so if I have any number, let's take 2 to the power of any number, let's say 2 as well, and I times it by the same base, so the same big number, 2 to the power of 3, that's the same as saying 2 times 2 times 2 times 2 times 2. Yeah, that being our 2, oops, that being our 2 squared, and that being our 2 cubed. But you can see now that we've got, essentially, we've got 2 times 2 times 2 times 2 times 2, which is 2 to the 5. So the trick is, if you've got x, as in x could be any number, to the power of any number, times another x to another number, where this x is the same as this x, the base is the same, then all you do is you add them together, and you go, that's x to the n plus m. And we can see that in that example there, where you got 5 being 2 plus 3. So here we've got 7 to the 5 times 7 to the 3. So 7 to the 5 times 7 to the 3 is 7 to the 5 plus 3, which is 7 to the power of 8. Dividing is similar. Instead of adding, you take it away. So 5 to the 9 divided by 5 to the 3 equals 5 to the 9 minus 3, which is 5 to the power of 6. And that's our answer, 5 to the power of 6. Now here it says 2, getting a bit harder now, but 2 to the 9 times 2 to the 4 over 2 to the n equals 2 to the 8. Now our job, what we want to do, is to find out what that n is right there. And the way we're going to do that is we're going to play around with this a little bit. We're going to go 2 to the 9 times 2 to the 4 is 2 to the 9 plus 4 over 2 to the n, and that equals 2 to the 8. We know that. So just then we said, I said about dividing and you take it away. Well, this thing here, this fraction right here, is essentially exactly the same as dividing. So that's going to be 2 to the 9 plus 4 minus n equals 2 to the 8. Now you can see that here and this, they've both got the same base, and then all we need to do is just find that index. So we know that 9 plus 4 minus n equals 8. So 13 minus n equals 8. So n must equal to 5. So let's carry on. Oh, sorry if you can hear my family watching TV. There you go. Welcome to holidays. Right, number 6. Expand and simplify this thing right here. So we're going to expand this. Now, if I expand this, I'm going to do 3 times that. I'm going to do 3 times that. Anything outside of the bracket, you times everything inside the bracket at the same time. So that equals 3 times 4x plus 3 times negative 5. And that is 3 times 4x is 12x plus, it's not going to be plus though, is it? Because 3 times negative 5, which is minus 15. Okay, well, that's the first one. And then I've got 4 times 2x plus 1, using the same way. That's 4 times 2x plus 4 times 1, which is 8x plus 4. So it says up in the question, it says 3 lots of that minus 4 lots of that. So I've worked out 3 lots of that, which is that, and I've worked out 4 lots of that, which is that. So I'm going to do 12x minus 15 minus 8x plus 4, which is 12x minus 15 minus 8x minus 4, which is 12x. I can collect my terms together. Minus 15 minus 4. Well, 12x minus 8x is 4x, and minus 15 minus 4 is minus 19. So my answer is that. Right, next one is expand and simplify. Now, if you remember, we did this in class about expanding these two brackets, and we used the FOIL way of doing it. So we said first ones, outer ones, inner ones, and last ones. So my first ones are y times y, which is y squared. My outer ones is 3 times y. My inner ones is 8 times y. And my last one is 3 times 8, which is 24. So I get, don't need to go to the next line for that one. Y squared plus 11y plus 24. Now, it's really important to see that on a question like this, what it's asking you to do is just expand and simplify. We're not trying to find out what y is. Here, the next part is expand p times 5p squared plus 4. Well, the same thing again. We've got p times that and p times that. So we've got p times 5p squared plus p times 4, or 4 times p, because it doesn't matter. Remember before we said about the law of commutativity, p times 4 equals 4 times p, and in algebra we just write 4p. So here we're going to do the same thing, use that law of commutativity, and I'm going to say that's 5 times p squared plus 4p, which is 5 times p cubed plus 4p. So my answer is 5p cubed plus 4p. That's question 6. Okay. A tunnel is 38.5 kilometers long. A train travels it in 21 minutes. And work out the average speed of the train. Now, an important thing is it gives your answer in kilometers per hour. At the moment, we're working in minutes, so we have to change something later on. Right, well, kilometers per hour, which we're working out, is our speed. And to work speed out, it's distance divided by time. So if it takes a longer time, speed equals distance over time, yeah. If the time is longer, then the speed is shorter. That's right. Because if the time gets bigger, this fraction gets smaller and the speed gets smaller. So if time is longer, the speed is longer. If the time is smaller, the speed is further. Similarly with the distance. So let's plug in some of these numbers anyway. We've got distance is 38.5, and I'm just going to do over 21, which according to my calculator is 38.5 over 21, which is 11 over 6, which is 1.83. Now, 1.83 recurring. Now, this is the odd thing, because if we think about it, right, it's 38.5 kilometers long, and it takes 21 minutes, so less than half an hour or something like that. If it were kilometers per hour, and the answer we got is 1.83, then it would take ages, because it would take, like, I don't know, 10 minutes. No, hang on, it would take if this were kilometers per hour, and it was 1.83 kilometers per hour, then it would take something like 10 hours to get there. Because let's call it roughly equal 2. So 2 kilometers in 1 hour, and then you've got 38 kilometers. Then you're looking at, oh no, sorry, it's about 20, it would take about 20 hours. But it doesn't say that, it says 21 minutes. So something must be wrong. And the thing is that it's this guy right here, because that's 21 minutes, and what we want is speed in per hour. So we need to change 21 minutes to hours. Well, 21 minutes to hours is 21 divided by 60. I'll explain why. If you had 30 minutes, that's half an hour. 30 divided by 60 is the same as a half. Right? They're equivalent fractions. You can actually put that into your calculator, put 30 over 60, and it equals a half. So 21 minutes is 21 over 60, which is 21 over 7, which is 0.35. So this guy right here equals 0.35. Right. Okay, so now we can use this guy here, and we can put that into our original equation. So we've got 38.5 over 0.35. So over, when I say over, I mean divide by, right? So 38.5 over 0.35 is 110, which makes a bit more sense. Bit of a slow train, bit rubbish really. Okay. Ooh, to make this tunnel, a cylindrical hole of 38.5 kilometers long was drilled. The radius of the cylindrical hole was 4.19 meters. Work out the volume of earth which was removed to make the hole. Give you answers to 3 significant figures. Right, so if you think about this hole, this cylindrical hole that they've made, for this tunnel, this was, I don't know, like say in the side of a mountain or something like this. My mountain, that's what my mountain looks like. Good mountain, I think. And they wanted a train coming out both sides like this, but they need to get rid of the stuff in the middle. So they drilled a big hole through the middle and just took out all the earth. Now, how big is that hole? They're just basically saying, what's the volume of this hole? And going back to our original, our front page here, it's actually a cylinder right here. This is not too bad, this one. I'm going to use this thing here, volume of a cylinder, and it says pi r squared h. Okay, so I'm just going to write that down. Where's it gone? Pi r squared h. Here we go. So pi r squared h. Well, I know what the radius is because it says it in the question. So r is 4.19. Pi is the pi on your button. H, though, is in this one is the length of this thing. Now, you might be tempted to put 38.5, but that's 38.5 kilometers, and here is meters. Now it's asking the word in the question. It asks. I get rid of that picture. It's a rubbish picture. And we'll just draw another one like this. So we've got 4.19 meters, but we've got 38.5 kilometers, which screws things up a bit, and they want the answer in meters cubed. So what we're going to do is we're going to convert that to meters. So we're all using the same unit. So pi, my favorite, times 4.19 squared times. Now, if it's 38 kilometers, there are 1,000 meters in a kilometer. So 38.5 times 1,000 should be check 38.5 times 1,000 on the calculator is 38,500. So go back to our question, 38,500. Now I'm going to shove that into my calculator. Pi times 4.19 squared times 38500 is, my goodness, massive. Right, the answer is 2123433.419 meters cubed. Now it also says, to give it to 3 significant figures. That just basically means you look at the first 3 numbers right here. And the next one, if that was a 5, it would go up to 213, and all the rest would be zeros. And if it's less than 5, so 4, 3, 2, or 1, it just rounds down to 4, 3, 2, 1. Oh no, I've written that wrong as well. Come on. 2, 1, 2, 0, 0, 0, 0. So our answer here is 2, 1, 2, 0, 0, 0, 0. If you're not sure about significant figures, don't worry about that for the time being. We'll come back to that. Okay, next question. We're almost there, about halfway. Shri invested $4,500. So rich. After 1 year, she received $200 interest. Work out 270 as a percentage of 4,500. All right, so she put in 4,500 and she got 270 as interest. So interest we work out as a multiplier. So for example, let's take $120 and I want to work out 50%. So I can work out 50%, and that's going to be $60. Now, 50%, when we're doing this kind of percentage multiplication, we always write as a decimal. Right, so we'd write 120 times 0.5, also that equals $60. So we've got 4,500, go back to the question, 4,500 times something equals 270. Well, that's something, we usually use something in place of the something, we use our friend X. And remember when we were solving equations, if we've got this and we've got this number here, to get rid of it, we divide both sides by that number, 4,500 divided by 4,500. And we get x equals 270 over 4,500, which I do believe is 3 over 5, which is 0.6. Let me just have a quick check on the calculator. 270 over 4,500. Oh, 0.350, okay, 0.06. So that means, so 0.06 is our answer, but that's a decimal. To get to a percentage, times by 100. That's the rule. Times by 100 is 6%. Karina invested an amount of money at an interest rate of 4.5% per year. After 1 year, she received $117. Okay, so this time we don't know how much was invested, so we'll call that X. But we do know that it was a rate of 4.5%. Now, as a decimal, that's 0.045. You just divide 4.5 divided by 100, the opposite of timesing. And that equals 117. And we're going to divide both sides by 0.045. Divide by 0.045. And we get 117. I can't do that on my head. 117 divided by 0.045, which is 2,600. And a good trick for this type of question is that if you end up with a number which seems about right, or is a nice whole number, it's probably going to be okay. If you end up with some kind of like really, really random, horrible number, then it's probably going to be wrong. Ravi invested amount of money at an interest rate of 4% per year. At the end of 1 year, interest was added to his account. Right, so he's going to have his original amount, X, times 0.04. That's going to give him the dollars, but it's added to his account. So this here is the interest plus X, which is the original account that he had. Okay, so and that equals 3328. Now, I can see that there's a factor here of X in both of those things. So I'm going to take out a factor of X. X times 0.04 is 0.04. X times 1 is a factor. So I end up with X times 1.04. Okay. And now I can just do the same thing as I did before. 3328. And we get 3328 divided by 1.04, which is 3200. X equals 3200. Looks nice to me. Now, this 1.04 here, that's always the multiplier, including the original amount. Okay, original amount. So if I invest a, come on computer, $100 in a bank at 5%, I know that at the beginning of next year, I'm going to get $105. If I want to use that as a multiplier, I have 100 times 1 plus 0.05. So 100 times 1.05, and that's 105. Right, I'll just should I look at the last one? Yeah, we'll do this one, last one, question 9. Right, we've got 4, ooh, bad start. 5x minus 4 equals 2x plus 7. We need to collect all of our x's on one side and all of our numbers on one side. So I'm going to minus 2x from both sides to get rid of my x's on the right hand side. So I'm going to get 5x minus 2x, which is 3x minus 4. Now 2x minus 2x is 0, so I'm just left with the 7 over there. Now I can add, I think I'm going to add 4 to both sides to get my numbers together. So I end up with 3x equals 7 plus 4, which is 11. And same as before, I'm going to write that come up here, I'm running out of room. 3x plus 11, oops, no, 3x equals 11. I'm going to divide by 3, and I'm going to get x equals 11 over 3. Not particularly nice, but there you go. Right, this next one's okay. We need to get rid of this 4. So remember, if there's something in the denominator and we want to get rid of that denominator, we just times by everything that's in the denominator. 2y plus 3. So times by 4 will get rid of that 4, but we're going to have to times everything on the other side by 4 as well. So 7 minus 2y equals 4 times 2y plus 3. And that's 7 minus 2y. I'm just going to expand this bracket. It's 4 times, we did this earlier on, 4 times 2y, which is 8y, plus 4 times 3, which is 12. And now we've essentially got the same type of thing. I'm going to do it the other way around this time. I'm going to do plus 2y to both sides. So I'm going to collect my y's on the other side. And I'm going to get 10y plus 12. Then I'm going to minus 12 from both sides. And I'm going to get 7 minus 12, which is negative 5, and 10y. And then I'm going to divide by 10 as my last step. And I'm going to get negative 5 over 10 equals y. I'm going to put that into my calculator. Negative 5 over 10 is negative a half. So y is negative a half. And I think we will leave it at that for the time being. Now, if you have questions about the stuff that I've just gone through, do let me know. What we will do is, in the future, I will also start giving you like a half paper, and I want you to go away and have a go at doing it first, and then I'll make a video of me going through the questions, and then you can have a look at how well you did. Okay, hope you're all well. Ta-ta for now.